it switches between the two available audio tracks.
Hi folks, it's 3D printer review time. I was sent this printer by these people, Reichelt. They very kindly sent it to me to have a look at it. Reichelt are a big distributor, kind of like RS or Farnell or someone along those lines. So they do lots of the kind of products that, if you're anything like me, you'll be interested in. Printers, 3D printers, Arduino stuff, Raspberry Pi stuff, bolts, nuts, screws, components, integrated circuits, that kind of thing. Anyway, they're trying to get their name about into the UK some more. They're trying to make inroads to the market. So if you're interested in any of that stuff and you're thinking about buying something, it's certainly worth having a look at their website. Anyway, into the review of this thing. For full disclosure, I was sent this printer for free. I get to keep it, but all the bits I've had to buy to review it, I've paid for with my own money. So we've got 7 rolls of filament. I've bought the extra extruder head for it, which I'll fit in another video. I'm planning on adding a heated bed to it as well. So I've spent a couple of £100 just to be able to review this thing. So I figure I can give an unbiased review of it. Anyway, we'll start off at the end and we'll look at the results that we can produce, and then we'll get on to all the issues I got along the way. Let's go. So here's the results of my latest print job. This took nearly 14 hours, so I've had to leave this whirring away during the night, and I haven't attempted to take any of these off yet. This is the BuildTak build surface. I wasn't expecting to like it, but actually it's performed really quite well. I've been rather pleased with the way that's been working out. Just assemble all these things together. It does the job nicely. It's been holding things down quite well. It's been holding ABS down quite well. So here is an ABS print. ABS is terribly tricky to print with, and it contracts by up to about 10% after you've printed it. But you can see the bottom part of this, actually, where I've got this brim round, it's stuck down it quite nicely, and it's only when it's got 3/4 of an inch up that it's the warpage on the ABS has caused a problem. So this is the 3D printed clamp that's going around. It's called the ice crusher, for ice cube crusher or something like that. This orange version was printed on my Ultimaker. I was using a 0.6mm nozzle at the time, but I do have another one printing just for fair comparison. But as you'd expect from the Ultimaker, really no problems at all with that. And I mean, for comparison, really no problems at all from the Vertex either. Nice clean print, no over extrusion, no under extrusion, nice flat surfaces. Generally looks great. So I'm just going to assemble that together quickly and we'll give it a try. See if I can remember how it goes. So, I mean, really functional part straight off the printer, basically no cleanup. Print quality, I'd say that's as good as the Ultimaker in every way, shape and form. Actually, I've spotted something that's possibly better than the Ultimaker. Don't know if this will show up on camera. Where we've got the transitions around this hole, you can see there's little ripple marks here as the print head's vibrated after it's moved out to print this part. There's then been a bit of vibration afterwards when it comes back, and the same with this little arrow mark. You can see these little vibration marks where the print head on the Ultimaker has been shaking about a bit, but they're significantly reduced, or basically not really visible at all, on the Vertex. So possibly even giving me better quality out the box than the Ultimaker. Not entirely a fair test because they're not printing at quite the same speed, though they both do take the same amount of time to complete this print job. And the Ultimaker used a bigger nozzle, but again, that shouldn't affect this kind of vibration pattern. So very good on that respect. So we can have effective comparative results. I printed out a bunch of these benchy benchmarks. So this one here is in white ABS printed on the Vertex. You can see we've got a little bit of stringing there and a bit of a sag there, but on the whole, really, really nice looking print. No overhang, no overlap, minimal stringing. The 3D benchy on the back is, well, the 3D benchy on the back is almost readable, but not quite. But certainly great looking print there in ABS. For comparison, here's the Ultimaker's ABS print. Again, really, really nice print, no over extrusion. 3D benchy on the back, not quite so easy to make out, but still there. Again, a little bit of sag there on that overhang, but very, very good quality from both of them. Into ABS, this is the Ultimaker doing black rigid ink ABS. Superb finish on there. Not quite so good on the Vertex. And I mean, this was actually the first time I used the filament, and I was doing it with the fans off, so I thought perhaps that was the cause of this sagging and over extrusion here. But the second print with the fans on gave a very, very similar result. So not quite as good on PLA, and also noticeable on the funnel at the top here. I think our temperature on the extruder, on the hot ender's got a bit too high on these particular parts, so they don't look quite as crisp as they do from the Ultimaker. And just for a third comparison, here's done using Ultimaker's own silver PLA. It was the spool of filament that came with the Ultimaker, and again much cleaner up the top. Quite a lot of stringing from the Ultimaker using the PLA, but nothing that doesn't clean up just as soon as you touch it. So not bad looking at all. Very good on the benchy results. Basically very similar quality to the Ultimaker 2. Apart from this, and I'll talk about this problem with the hot end temperature in a minute. So I'll look at a couple more functional parts here. This is white ABS printed on the Vertex. The black one is PLA printed on the Ultimaker. Again, there's just nothing to choose between them on the quality at all. Lovely smooth surfaces, lovely printing, good layer adhesion, just absolutely superb results I'm getting from it. It took a bit of fettling to get things working right, so I'll take you through a brief history of print jobs. So on the left here we have a soldering iron, a solder roll holder, and that's a space for a desolder pump and for a flux pen there, and for some soldering iron tips and things like that. This was the very first thing I printed on the Vertex, because I had attempted to print it on the Ultimaker and it had suffered a clogged nozzle at some stage along the way, so these layers hadn't adhered properly, and then the print head ran into it and I was left with spaghetti. So although the Ultimaker is a good printer, it's certainly not beyond the ability to have failed print. So I was very pleased that using ABS, which is a more difficult plastic generally than PLA, I was able to get such a good first result out of the Vertex. So you can see it's very, very capable of delivering quality that matches a printer that's 3 times its price. The Ultimaker's round about 1,500 quid these days, I believe, and this is closer to 500 quid. You have to assemble it yourself, but if you like building things, as I do, that's not necessarily a downside. So if you're looking for something like the Ultimaker 2, very comparable results for a third of the price. Now, let me talk about the downsides with this printer. First of all, I'll give you a quick demo of the noise levels of this compared to my Ultimaker 2. This printer is a lot noisier. Most of it is stepper motor noise. To begin with, I did have a few issues with strange grinding noises, but I generally managed to calibrate them out just by setting up the printer better. There's a few quality issues. The Ultimaker is a superbly built machine. This is pretty close second place, There's a few little gaps around the case that maybe it's because I didn't assemble it quite as well as I could have done, but I did put 2 full days into building this kit up. So the fact I was unable to get it to meet up perfectly is a bit of a shame. I had a few issues with adhesion to this build-tack build surface. For the first day and a half or so, I had nothing but trouble with it, and then I redid the bed levelling and pretty much ignored Velleman's instruction to use 4 sheets of paper and started doing it with 2 sheets of paper, and magically suddenly everything was sticking beautifully to the build tack, no problems removing prints. It's actually, I was expecting not to like the build tack print surface, and it has gone up massively in my opinion. I actually quite like this build tack stuff now. I'd never tried it before. I was expecting it to be not very good, and actually it's really quite good. It seems to do an excellent job holding ABS down to the bed. So as long as you get the bed height set exactly right, then it works out quite well. I had a few problems with the Repetier software that they recommend you use with it. It didn't seem to have the bed size set correctly, so although in the diagram on the screen everything lines up nicely, the actual print job just truncates at that point and doesn't carry on any further. After my problems with Repetier failing to align things on the print bread properly, I was delighted to discover that Cura 2.7 beta actually has very good support for the Vertex and lets you go in and configure all the settings, whether you've got a heated bed or not, set the nozzle diameter and everything. I did some tweaking to the G code because by default I didn't like the way it tried to prime the extruder, so I've added an extra feed in there, and I wanted the bed to finish all the way down at the bottom. Yeah, that line. So I just added an extra command to move the build plate down to the bottom when a print finishes. I'm generally a big fan of Cura, having used it for a couple of years, so it meant I didn't have to learn a new workflow, so always happy with that. Now the over extrusion problem I was talking about with the chimney on the boatie, let me show you in more detail that. I'm going to have to turn this off. Another issue, there's no power switch on this thing, which means to actually switch it off you have to unplug it, and that's a huge weakness in the platform. So this is the actual hot end where the action happens. In this side here is the heater cartridge, which heats up this chunk of brass, and this set of wires here are the temperature sensor inside. And the way Velleman have implemented this is they've got the little glass bead temperature sensor, and they've wrapped that inside a layer of plastic or heat shrink or something along those lines, so you can feel a bulge in where it is, and you place that inside there. But the problem is this little fan here blows on these wires, and because the temperature sensor is actually insulated itself, the thermal conductivity up through these wires means when the fan is blowing, the temperature sensor reports a significantly lower temperature than this print head is actually at. So from my testing, I had my thermocouple hooked onto it, and it was telling me this chunk of brass was around about 260 degrees, but the front panel on the display was telling me it was struggling to maintain 228 or so degrees when I was trying to print at 245. So certainly this temperature sensor setup is far from ideal. It needs some kind of shroud around it to keep the breeze off it, or they could have put the wires in from the opposite side rather than having them routed up the front here. But that causes problems with maintaining a consistent temperature, and in particular I had big problems doing the first layer of print when the fan's not running, because having adjusted it so I got good prints and found that a particular material worked nicely at 225 degrees when it was printing, when the fan's not running and that's actually getting an accurate reading, that turned out not to be hot enough for the material, and I got all sorts of problems with clogs and the extruder motor skipping steps and things like that. So I'm not totally convinced that this design of hot end is really the best. So I'm probably going to change these hot ends out for something different in the future. They work well enough once you've worked out all the quirks and managed to get the temperatures set right, but the temperature you dial in is not actually the temperature you get, so you have to do a bit of fettling in the software to allow for that. There are a few elements of this printer that I'm just not that keen on, although it's quite nice that they made provision for tying these cables in. The way they get you to route the cables through, you have no slack at the bottom and all the slack ends up at the top end, and it looks kind of untidy. So I did a quick check on Thingiverse, thinking I'm probably not the first person who's thought these cables are untidy, and I found this fantastic looking set of cable tidies for it. So I printed those off on my Ultimaker, and I'm going to fit those to this printer at the same time I fit the second extruder. In terms of the general build process for this kit, there's a few things I would like to call out. One of the steps in the instruction is getting this bar of the print head, and similarly this one, parallel with their guides at the back, and they just show this using a standard micrometer depth gauge, but there's no way to properly align that, and it's basically impossible to do correctly. And again, Thingiverse came to the rescue with this amazing set of alignment tools. These just should be a standard part of the kit Velleman supply. It makes it so much easier to build. It removes any uncertainty. They'd be pennies if they were mass produced, these little alignment tools. Whoever designed these, thank you so much. You made it possible to actually get this thing running smoothly. Without the alignment being done, I found that one or the other of these guys would make kind of a grating noise as it went along, as it vibrated back and forth a bit. Another issue I ran into with this printer that I didn't like, this Z-axis rod here has a huge unsupported length, and when the bed's moving at speed up and down, this rod tends to wiggle round and round in circles and makes a very loud buzzing noise. Again, I turned to the good people of Thingiverse, who had made this axle support. Unfortunately, it doesn't quite line up centrally on my printer. I'm not quite sure why. It could do with being a couple of millimeters further extended, so I kind of bodged it with a shim and a failed print and a bulldog clip to actually get that lined up correctly for me, and that gets rid of a lot of the noise on this printer. But again, it should have been part of the kit really. It's definitely something that's desirable. It's another injection molded part or 3D printed part. It should just have come as standard with the kit. These are some of the plastic parts that were included with the kit, and they're just beautiful mouldings. There's no flashing, nothing to fault on them at all. I realised partway through building the printer that basically every single one of these plastic parts that Velleman have supplied is designed in such a way that you could 3D print them. They're all with a flat bottom. They'd all print beautifully. So I don't know if that was intentional, but certainly very, very useful. And I found that all the parts are actually available on Thingiverse as well, should you ever need to modify them or make them in your own models. So kudos for that. Very nice quality components that Velleman used. Another thing I wasn't too keen on, the plastic knob that they give you by default for the rotary encoder. It's not very deep, it's a very tight fit on the shaft, and if you have it on there, it's forever getting in the way of the SD card. So I used a spare one I had lying around, which is much more satisfying to use. One oddity in the software interface, the up and down directions on this rotary encoder are not consistent. So if I move down through the menus, you can see I'm rotating that way. I'll go and tell it to move an axis, but now to move down there, that's now incrementing instead of decrementing. So up and down has been reversed whenever you're actually changing a value of a number, which is just bizarre. So now that's up and now that's down. Very strange. There's a few other oddities on this printer. This downward firing fan here, which I think is supposed to keep the power supply at the back and the stepper motor drivers along here cool, It has no kind of shroud, and because it's placed directly in the centre of this panel, it has a tendency to actually create quite a lot of noise. This whole enclosure is acting like the base enclosure on a loudspeaker, and with the fan slap bang in the middle there, I don't know if you can hear the noise from my microphone, but it makes this fan unnecessarily noisy. Now, quite a few people on Thingiverse have printed out alternative fan mounts for this. I did try one fan shroud out, but it didn't actually work very well. Things weren't getting any cooler, and it tended to flap about in the breeze a bit and actually made things noisier, so I took that back off again. The empty triangle at the front, I fitted this nifty little bin in, which is actually really useful because you do get bits of fluff and things lying around there, and just having somewhere to sweep them into keeps things nice and tidy. So that's a fantastic addition there. This extruder arrangement on the side here, I'm not totally happy with. It's okay feeding the filament in, but then it seems that where the filament exits out of the top isn't in a straight line. It seems to be over that way a bit. So every single time I've tried to get the filament in so far, I've had to get a pair of tweezers and tuck it so it meets the hole at the other end. And although I printed this white clamp here to make it easier to squeeze the lever, I've actually found it necessary to put a cable tie on there every single time so that I can then use my other hand and get the tweezers to get the filament up the tube. So I'll be printing alternative ones of those off. Now, the assembly of this is generally pretty enjoyable, but there are a few bits where you just don't have enough hands. And if you can see on the top here, there's like a small pile of rubber dust here. I think what's going on here is, in order to tighten these stepper motors down, you need a hand on that side for the Allen key, hand on that side with the spanner, a hand on the inside with the Allen key, and then you just get your third hand and level this stepper motor up. Because I've only got two hands, I've actually ended up with the situation where the back of this motor is slightly higher than the front, and that's causing the belt to try and pull itself in this way all the time, and that's causing those two belts to rub together. So in terms of alignment, they would have been correct, but because that stepper motor is not totally flat, it causes the belt to wander. And of course the same problem happens on the other side with this set of belts down here. I'm not a huge fan of this spiral wrap cable tidy either. I know it's supposed to make things look nice and tidy, but it just never gives a completely smooth finish. There's always gaps or overlaps in this spiral wrap. I might try and find some kind of fabric covering for that instead, because it just looks a bit untidy. Another oddity I found, out of the box I was getting very, very bad, out of the box the extruder was struggling to push the filament through, and I found this extruder steps per millimetre. Out of the box it came at 200, but having actually calibrated it by measuring the filament extruded, I found a value of 140 actually worked much better, and it was when I changed that value to 140 that suddenly all my printing problems vanished and I started to get good quality results. That should have been done out the box, or it should have at least been documented. The fact I had to spend a couple of evenings struggling until I realised what was going wrong. If this was your first 3D printer, you may never get past that point. You may never work it out. There's so many settings buried in there that knowing what each one is for a newbie might be a bit of a challenge. But with everything set up correctly, it certainly gives fantastic results. So, having lived with this printer for a week since I built it, how do I feel about it now? Well, I have to say, I actually quite like it. It's giving me results of the same quality as my Ultimaker. I have suffered clogged nozzles whilst doing this, but I've also suffered clogged nozzles on the Ultimaker. I've been printing things side by side to try and get comparative results, and it's certainly no less reliable than the Ultimaker's been. I had clogged nozzle while trying to print this clamp in ABS. I've had failures printing that soldering iron station thing. Yeah, it's basically, the quality is as good as the Ultimaker once you get it up and running right. if you want that level of quality and you don't want to pay 3 times the price, it should certainly be an option. Now, I'm not comparing this to any of the other 3D printer kits out there on the market because I've no experience with those. I know the i3 Prusa, the original i3 Prusa, is very popular at the moment, but that's a more expensive kit. I think the i3 Prusa kit is round about £750 mark. This is about the £500 mark. I think it represents good value just as a 3D printer, but for me the real eye-opener has been the actual experience of putting the kit together and working through the issues. I now know things I never knew on the Ultimaker. I know that this is a Marlin based board, which is some kind of RepRap printer format board. All the source code's open source. It's actually an Arduino Atmega 256 on there, so you program it through the Arduino interface, which is something I've got experience with. I'm not scared to mess with the code on here and make changes. The most exciting thing about this for me is that I can add on a second extruder to it. So I'll be doing that in a future video. I wanted to get this review video completed while it was in its as shipped configuration before I start making modifications. I'm going to add on this second extruder first of all. I've also ordered the LED lighting kit from Velleman for this, which was quite reasonably priced, 20 quid, something like that. So it'll have RGB LED lighting, which is again an improvement over the Ultimaker. The noise level I think is down to the stepper motor drivers that are used on here. So I've dropped 36 quid I think it was on 5 different stepper motor drivers, and I'll be swapping them out in a later video to see if I can get the noise level down to the same amount as the Ultimaker. So all in all, it's a pretty good kit for the money. There's a few things that it would be nice if Velleman had shipped alignment tools for getting the stepper motor set right, getting the guide rails all parallel, making sure the belts don't crash into each other. Those would be fairly easy to resolve. So hopefully Velleman will make some modifications to their kit. Hopefully they'll see this review. I don't know if they actually look at YouTube at all, but hopefully they'll see this review and decide to add a few extra bits into the box, because it would be cheap and easy and it makes things nice and straightforward. One more thing while I'm thinking about the actual assembly of the kit. The assembly instructions have you fit the second spool holder very early on, and that actually, as soon as that goes on, it makes it nearly impossible to access the bottom of the printer, which you need to do when you're doing the wiring looms and all sorts of things. So for a lot of the build I had this balanced on cups and cardboard boxes and things. If the assembly instructions had left the second spool holder until the very end, the whole assembly would have been easier. Anyway, that's it for this review, folks. Hope you enjoyed this video. Join me in a future video and I'll show you how fitting the second extruder turns out. It won't just be fitting it, I'm going to work out how to actually use the software, try some dual colour prints and try some soluble infill. So that's going to keep me busy for the next week or so. Anyway, hope you enjoyed this, folks, and thanks for watching. Bye!